Last one out of 4.3. We're going to do some problems that will be very similar to what you will find on your exam because they are quite internet proof. You actually have to know what the hell you're doing because they just come straight from my mind. You're not going to find them anywhere. I'll just randomly come up with something right before I give you your test and you get to do it. So these are going to be just like problems 24 through 31 of your text. I'll get a couple of them posted up for you later. Let me tell you, I was terrible at these even as an instructor. I'm not, we're going to like sketch curves. Look something like this, give you a bunch of information, then ask you to sketch the curve. It won't be exact because we don't give you any functional values, or I don't. I was terrible at this. I'm just not graphically inclined. I don't see it well. I don't graph well. I don't do those. And there's so much information, I just couldn't figure it out. And then my old office mate, who's the man, I miss him to death, is Professor Bozos, or Andre. He's now down in Sac City. They're quite lucky to have him. He taught me this method, and it's, dude, from somebody that struggled, and then he showed me this and went, oh shit, I can graph anything. You can play this game, I can do anything. He showed me this method. So let's just jump right into it. Enough babbling on about the fact I miss my old office mate. So all this information, let's try and organize it in a manner that works for us. So we have our first thing. Where the derivative is greater than 0. Where is it increasing? So this is telling us where we're increasing, right? Our x values. It's just telling us where. And we'll be back for that. The next piece of information right below it is telling us where the derivative is less than 0, or where's the function decreasing. And then it gives us 3 separate intervals. So we'll know where that is. All right. Wow, this is a lot. Now we move to the next, and it's like, all right, now it's just telling us about the second derivative, where it's greater than 0, where it's concave up. And then it gives us our 2 separate intervals. Lastly, of course, we have our where the second derivative is less than 0, where it's concave down. Concave down, it gives us a couple little intervals right here. Whew. All right, so we know where it's increasing, decreasing, concave up, and concave down. All right, cool. Now we keep cruising through, and we're like, all right, f prime of -1 equals f prime of 1, which equals f prime of 3, which equals 0. Oh, that's saying at -1, at 1, and at 3, the slope of the tangent line equals 0. So those are real suspects for local mins and maxes there. What's disappearing? That f prime of 1, where the derivative equals 0, those are local min and max. Those are candidates right there. Well, at least the slope of the tangent line is 0. Possible. Doesn't have to be, but it could be. And then next we have a f double prime of 2 is equal to f double prime of 4, which is equal to 0. And you know what those are? Those are possible inflection points. Not necessarily, but that's where that shit will occur. Or where it doesn't make sense. But now we have the limit as x tends towards positive infinity of f of x is equal to 0. Now what does that mean? Do you remember back to our limit section where I think it was 2.6 for text, maybe 2.7? Get mixed up. 2.6. Limits as x tends towards infinity. What does it mean for it to actually go to a value? And if you remember back, that means there's a horizontal asymptote there. So it looks like we have a horizontal asymptote of y equals 0. And then now in our last little piece there, we have the limit as x tends towards 0 from the left. So as x tends towards 0 from the left, it says that our functions go to negative infinity. So the function goes towards 0 from the left, it goes down to negative infinity. That sort of idea. Okay. Cool. Shoot. Got it? Just run right through and just put it all together, huh? You can do it. Oof. That's kind of how I felt. I'd look at it and just be like, it's just too much. I can't keep all that information. I had no formulaic way of doing it. And then my buddy Andre said, watch this. No, watch this. This is his style. He's like, all right, just go underneath the graph. Make a couple lines. Now we're going to call this one f prime of x. And in between here, we'll call this one f double prime of x. And let's make another line. Let's do this so we can see it's all stuck in between. Cool? All right. Now, all we want to do is start looking through in these lines. We're going to start breaking this up into intervals. And I'll show you what I mean. Let's first look up here. F prime of x greater than 0, where it's increasing. We find that it's increasing from negative infinity to negative 1. Let's just look at that first one. So let's just block it off and go for anywhere from way over to the left all the way up to where's negative 1? Where's negative 1? Negative 1's right there. So let's go drop down to the bottom and just break it up. And go, all right. So anywhere to the left all the way up to negative 1, we know that we have an increasing function. So let's just draw an arrow increasing. All right, cool. Done with that one. Looked at that. Now let's block off the next one. What's the next one? 1 to 3, where it's increasing. So let's look. Let's find 1 on our graph. 1. Well, let's find 3 on our graph. Let's drop it down and let's block that stuff off. And go, all right, cool. From 1 to 3, we're increasing. Believe it or not, this is the second time I've done this, and I have this shit backwards. I couldn't figure it out. I felt stupid. And I've actually gotten much better at these. Oh well. Moving on. So f prime of x is less than 0 now. Well, I think it's probably going to be in those blocks that we haven't written. But let's just see. So it says from negative 1 to 0. Not negative 1 to 1, but negative 1 to 0, we're decreasing. Let's block off negative 1 to 0. Negative 1 to 0 is right here. And it says we're decreasing. Okay. So we write a little arrow down saying we're decreasing, and now we look and we see that from 0 to 1, we're also decreasing. All right. But there's something weird going on there at 0. Something weird going on there at 0. Something weird happening there at 0. I wonder what it could possibly be at 0, why that would be decreasing and decreasing, and it just wouldn't be the same thing. But, I don't know. All right, moving forward. And now we look at our last piece, and we're going, so from x greater than 3, we are a decreasing function. We are a decreasing function. It's a decreasing function. Sweet. I'll bet you can tell what we're going to do next. Why don't we drop down to our f double prime and start figuring out what the f is going on with our f double prime. Where is this? Oh, we go through and we're like, all right, f double prime. So concave up between 0 and 2. So let's block off 0 and 2. Where's 0? 0's right here. And 2's right here. And it says that we are concave up. So smiley face. Let's make a smiley face. Some arrows. Cool. Is it concave up anywhere else? Let's look. Oh, yeah, it is. From 4 to 3, it's concave up. So let's block off 4 to 4 to infinity. So there's 4, right? 4. Come down there. We're like, all right, cool. We're concave up. Yay, smiley faces. Good deal. Now, I'm going to sure as hell hope everywhere else it should be concave down, or maybe it's a straight line or something. I don't know. And then we got negative infinity to 0 for x's. So negative infinity up to 0. Cool, we're concave down. That's fine. Frowny face it. And then it says from 2 to 4, as we hoped. Neato, 2 to 4. Concave down. Well, shoot. I feel like we're a hell of a lot better off now than we were to start. You know what I mean? Now we got all that shit filled in. Well, now we can just use what's given to us. Anytime we get stuck, maybe refer over to the left and make sure that the stuff that isn't highlighted is getting handled. All right, and there's other ways. There's much better methods. You can find other people online to do it, but this is the way I do this. Now, let's see what can happen. And we're going to start graphing this, and we say that from negative infinity up to like negative 1, we're increasing, but it's concave down. So something like this. Is that cool? Is that cool? Something like that is increasing. But then it's got to decrease again right here, right? It's got to decrease after that. So maybe we have a peak. Oh, shit, maybe that's a local max. So what's going on at negative 1? Do we have anything saying anything about negative 1? Is there anything in here about negative 1? Oh, it equals 0. Oh, so we have this increasing, then it's decreasing, and it's concave down, and we have a derivative at negative 1 that equals 0. What are you thinking, huh? What are you thinking? Let's try this again. I think it might be doing this. Peak. Well, however, make your peak right there. And then it says it's going to decrease, but we have that issue at 0. So we know it's going to start decreasing, coming back down. But we have an issue at 0. And where was that issue at 0? Oh, yeah, that was right back here where we said that the derivative, or the limit as x tends towards 0 from the left is going to negative infinity. So that means that this thing, as it's approaching, it's just going boom, and that would make sense. It's an increasing function all the way up to -1, where it peaks, and then it decreases down to 0, where it's concave down the whole time. Cool, we've handled negative infinity up to 0. Now let's go over to the right-hand side of 0. And we're going to have to do some thinking. So we know it's decreasing, and it's concave down all the way to 1. So we have a vertical asymptote. Where the hell do you think? Do you think it's just going to come out from here? And it's just going to start right there? Hell no. Come on. It's either going to be, it's either going to be coming up from here, but that's increasing. That's not possible. Or it's coming down from here. I think that makes a little bit more sense since it's decreasing coming from the top. And we need it to be concave down. Well, that would be fine. We kind of draw that thing parabolically because we're going to have where it's going to be increasing at 1. So let's bring it down. Let's go. Now your height might not be this low. Huh? Maybe it's going to be a little bit higher on the graph. This is just how I'm choosing to draw mine. You might see there's a trick at the end. Now, how's this going to work? Is it saying that, all right, we hit a valley here. Now is this, f prime of 1, that's equal to 0. So we should have a little valley. We should have a local min hanging out right there. And then it says we're going to increase after that, and then we're going to decrease again at 3. So I'm thinking this might do something like this. And change, right? Another peak right here, because we're going to change. And then the concavity changed right in here. Right in there. So it just kind of gave a little concavity change. That kind of makes sense? All right. Now here we go. It now says that it is decreasing. Decreasing on the rest of this. Oh, but that doesn't work. Do you see why that doesn't work? You see why this can't work? The concave down was cool, but that's not concave up. We can't do that. That's not allowed. It's got to change concavity while decreasing. So what do you think? Maybe a little something like this. And therefore, it also handles our last little piece. The limit is x tends towards infinity. It's going towards 0. So we still find that we have our inflection point right here, about where it changes. About, right? Doesn't that kind of change, inflection? Where f double prime of x equals 0. And then another one right there. Wouldn't that handle our last two pieces here? At 2 and at 4, we had our inflection points. So there we have it. We have a graph. Start to finish, 13 freaking minutes later. Gonna be 14 by the time I wrap up all my babbling. So there's some curve sketching. How we can run through this, do this in a formulaic way. There's a lot of little tricks with these. So do the ones out of the textbook. They're really good practice. So, all right, I'll see you next time for L'Hopital's. It's good news, bad news. But I love this shit, so we're gonna get into it. We'll hit this stuff hard. All right.